Good afternoon. It's great to be back in New York City, back in this incredible museum. So thank you for having us and letting us be part of this conference. So today, we have three topics that we're going to review. The first one is how MoMA prioritized its capital expenditures. And it's based on a facility condition assessment that was performed earlier on. But it's always, and I know you know, that it's difficult to prioritize how what do you do in year one? What do you do in year two? What do you do in year three? So we're gonna talk about that a little bit. And then we're going to provide some recommendations on how you help your capital expenditures. How do you extend the useful life of some of your building systems to get more out of them? And then lastly, there's a topic that's come up recently, and it's been in some of the topics of conversation, where energy codes are coming more in force, where local ordinance are now requiring energy efficiency, and that is affecting and reprioritizing capital expenditures. So we're going to talk about how MoMA is addressing some of these items, how they're coming into compliance, and then provide some recommendations and maybe some resources that you might be able to use if you're in the same situation. And then we'll get to questions and answers. So let me introduce the panel. We have Richard Stomber, who is the Director of Building Operations. Richard's been here since 2017. The rest of the panel is from Marx Okubo. We have Joe Milam, who's the Director of Mechanical Engineering. He's in our Atlanta office. We have Steve Schneider, who is the Director of our Fire Protection and Life Safety Systems in our San Francisco office. We have Courtney Vladica, who is the co-director of ESG, and she is in our Orange County office. I'm Kathy Spurk. I'm the co-lead of the museum group and the historic preservation group, and I'm in the Denver office. So we're covering kind of all corners of the United States here. So before we start our discussion, I just wanted to give you a brief introduction of why MoMA is here with Marx Okubo. So back in 2018, Marx Okubo performed a facility condition assessment on the building. We provided a comprehensive detail. It was a 10-year evaluation for the facility. It reviewed all the mechanical, electrical, plumbing systems, facade systems, fire life safety systems. It can be accessibility, resilience. However, it is a very holistic, comprehensive review of the buildings and a definition of all the facility needs. It enables the group, the stakeholders, to look at what are the immediate needs, the short-term needs, and the long-term needs for your facility, and how do you start prioritizing those needs. So we worked very carefully and very closely with facilities, looking at drawings, looking at all the building systems, looking at all the maintenance records, work orders, and coming up with a capital expenditure schedule for 10 years of multiple items. So Richard's going to start out our session by giving you just a brief overview of the history of MoMA. Just kind of close here.
For the pointer.
Yep. Oh, where did it go? Let me find it for you.
It's okay. Without it.
Yep.
Well, thank you, Kathy. And just, I want to welcome you all again to MoMA, and hope you're looking forward to some time to walk through the museum and see our great collection that the team here has been protecting and preserving for you and displaying for you. Our exhibitions team is top-notch. If you get a chance to go to the 6th floor, you'll see just a work of art in itself about how that exhibition is displayed. Thank you. So, MoMA's been around for 100 years, I think it was mentioned earlier, and it's a conglomeration of buildings, as Nelson had mentioned. And these buildings were built kind of organically over a period of time. The museum was founded in 1929. It was founded off-site in an office building a couple blocks from here on the 12th floor. But gradually over time, the museum kind of grew organically from east to west on 53rd Street. So you're looking at the 53rd Street elevation, and you can see basically these different buildings and different constructions over the past 80 years. And we're looking forward to celebrating our 100th anniversary soon, so we'll hope you'll be back for when that happens. But the red outline is basically where our facilities are and where they rest. And one of the unique things is that MoMA is actually in 2 high-rise buildings. When you're walking, it's seamless to you. When you're walking underneath them or on the 5th floor through them, you're actually walking through, an 80-story residential building that was built in 1993 and a residential building that was just built in 2019. So, I think we're a very horizontal museum in ways, but we're also a very vertical museum. So we really rely on different things maybe than other museums do. Elevators are super important, escalators. And as you can imagine, all these buildings have their own risers and they're built at different times. But that being said, almost our entire existing campus was renovated in 2004. We had a major expansion in 2004. So almost all the equipment, mechanical, electrical, life safety, in these buildings, in the older parts of the buildings, pre-2019, are 20 years old at this point in time. And as mentioned, they do work pretty hard because they're working year-round. And in 2019, we were doing an expansion where we knew the museum was going to close for several months. And we had a window of opportunity to do projects in mass that we would not have had the opportunity to do once we reopened. So one of the overarching things for the facility conditions assessment was to make sure that our 2004 facilities were prepared to meet the demands of the 2019 crowds that we were going to get. So that was kind of the genesis of this facility conditions assessment. And you can see in 2019 our campus grew by about 100,000 square feet. As was mentioned earlier, we have other facilities in other places, but and we did facility conditions assessments of those facilities as well. But we're only presenting on this one today. And what we're doing here is we're really getting an idea of the final, a lot of times you'll hear about prospective facility conditions assessment or what one might bring. But this is really the final results that you're going to be seeing of this 2018 facility conditions assessment today. When Marx and Okubo concluded their services in 2018 to the museum, they basically handed the museum like a 10-year capital plan, which you're looking at now, that covered a range of different categories: structural, exterior envelope, MEP, life safety. They're kind of listed on the left side, and gave us like a 10-year plan of what that 10-year capital plan might look like. So this was the document that the MoMA stakeholders were kind of given to decide how to allocate this money. In the end, we didn't really go, this was not the plan that we went with. These are just kind of numbers that kind of had some reality. But you can see that the plan was very front-end loaded in 2019 because that's the period we were going to be closed. So there was a lot of work done in 2019 and plan. But really what we did in the end is we only went out like 2 or 3 years. We went to like a 3-year plan. It really became like a 4-year or 5-year plan due to COVID and some of the challenges we had. But we really intended to spend about $20 million over 3 years doing these projects and other projects that were also identified at the same time that are maybe non-deferred maintenance type of projects. There were 3 main priorities for MoMA. One was the life safety. The second was preserving the collection and our assets. And the third was to continue to provide a world-class visitors experience. And that really defined our job, the projects as we help go forward, particularly for the visitor experience, where you don't want to be doing construction and taking things out of service and reducing your exhibition space right after you open. So that part of that visitor experience was really embodied in the expansion and trying to wrap those kind of items up before. There were 2 other items that were kind of like quasi factors to consider. One of them was the mitigation of risk, which we'll talk about later, and how do you maybe evaluate risk on a number of different projects to decide how to proceed. The second is energy conservation, and that didn't really come up till later. We're going to be talking a little bit more about energy conservation here and maybe what was required to do, and what maybe its targets and goals are. But also that at the time, Marx and Okubo wasn't really looking at energy conservation, but that came into play a little bit later on. And if you just were interested in what our buildings look like from an overhead view, like a Google Earth view, this is kind of the grouping here. We have a number of different roofs, about 35, 36 different roof sections. Our cooling towers are on the roof of the high-rise building here. You can see them right there. Some of our mechanical rooms are on the 8th floor, and they're just kind of boxed into difficult situations. Our chillers are below grade. So you get an idea that access is very difficult, not only in the museum because of all the hard ceilings and the exhibition spaces and the double height spaces, but also just in terms of it's all spread out, and it's also can be high and hard to reach without closing the street or a sidewalk.
And these were the areas, Richard, that really came in to play as priorities. So the mechanical systems, roof replacements, skylights, and sealants.
Yes, and we'll go into each one of those.
So hello, I'm Joe Milam. I was fortunate enough to lead the team that evaluated the mechanical, electrical, and plumbing systems for the survey here. And one of the things that we identified during our FCA were three much older air handling units, large main air handling units that we had identified to be priorities to replace them. And those were replaced just recently. And then there's 75 or 80 other air handling units in the facility here. And we recommended that they retro commission those, refurbish them as needed. And they were a little younger units, so we were able to extend the life of those through the refurbishment and retro commissioning. And then it gave MoMA the opportunity to schedule some phase replacements in the future.
And thanks, Joe. And it was valuable for us because we only have the capacity to do so much at a given time. We knew these units, the air conditioning units, the air handling units, were approaching their useful extended life. But we knew that they would probably be good for a couple more years with some refurbishment. So this plan identified these issues, but also gave us the time and space and bandwidth to kind of pursue them over a longer period of time. Hire a consulting engineer, really take a deeper dive into these systems rather than just kind of replacing them as an ad hoc measure.
Another item that we identified was the steam systems. So MoMA purchases steam from Con Ed, the local utility. It's very expensive, it's dirty, it's problematic, and we recommended upgrading the main steam line and some of the steam system components. And one of the important things that we did was MoMA replaced the pneumatic pressure regulating valves on the steam mains with electronic pressure regulating valves. And this allowed them to more closely control the steam system, and they were able to lower the system operating pressure from 12 psi to 6 psi, and that resulted in approximately a 10% savings in steam usage for the facility. Richard's going to talk about that more because steam's important.
Yes, so if you're not familiar with New York, you can see the steam coming out of the street, manholes all over the place. So it's a fairly inefficient process, although it's supposed to be a byproduct of their power plants. I think they actually have special steam generating plants, though, to a certain degree. I think our steam is just steam generated. There's about 1,000 customers in the city, a little over 1,000. We're one of them. They tend to be concentrated in Midtown and in Lower Manhattan. But our building doesn't have any on-site combustion at all, except only for the kitchen, only for cooking.
Another area that we identified was the building management system. And as you guys are aware, it's asset protection requires very strict temperature and humidity controls, and that's accomplished by the building automation system, building management system. And we recommended some retro commissioning, not only for the air handling units, but for the building management system. BOMA's building management system has tens of thousands of control set points. It's lots of points. And so how do you evaluate those? Well, they were leading edge, and they actually used analytic software to come in and evaluate the set points and the sequence of operations. It wasn't quite AI, but it was the next thing to it, preceding it, and that helped identify a lot of set points that could have been erroneous or bad components or some sequences of operations that could be reprogrammed to improve equipment efficiency. And so that helped them develop ways to test, adjust, and balance and fine-tune the building operations.
You know, it's a hard decision, like when you're upgrading a BMS and all your other equipment's the same age. I think, you know, how do you decide to do that? And again, this plan identified the BMS as an issue. It was not picked up as one of the initial projects to be funded. There are reasons for that we'll see in a couple minutes. But what's happened in the meantime is energy efficiency became a higher priority. The controls, building controls, automation controls are inherent in that. So again, the consulting engineer was hired, and we basically did a full design for a full replacement of the BMS, which is going to probably precede major equipment replacement. So that's the path that MoMA took, is to replace the BMS kind of first on the front end. And I'd have to say I'm pretty happy with the progress. So if anybody has any more questions about that later on, it's kind of a tricky thing to decide what to do first. But again, the plan identified the issue. We elected not to do it right away because it wasn't one of our major risks. But over time, it is one of the major projects that we're working on now.
So as you guys are aware, museums operate 24/7, 365 days a year. Okay, so it's difficult to shut those systems down. You have increased run hours on your equipment. That increased run hours reduces the useful life of your equipment, right? A chiller might run 30 years in an office building. You may only get 20 out of a museum. Just depends. And so this slide is to help us think about maintenance. You cannot defer maintenance. As difficult as it is to come in and replace things, and you don't want to shut exhibitions down, you don't want to close the building, you got to come in and plan for those replacements. You need time to design them, to bid them. A lot of the equipment has long lead times. Those lead times are really long right now. Chillers are 14 months, 16 months. Electrical switchgear are 20 months. So you need to be thinking about this way in advance, and coordinating the shutdowns with your exhibits, right? Another thing we wanted to bring up was, there are incentives and rebates out there for efficiency upgrades. Many places, many utilities offer that. And not only do they offer incentives for the equipment, but some of them offer incentives and will pay for the studies to help you evaluate your systems.
Yeah, so to expand a little bit more on that, everyone's favorite topic is how do you pay for it? And so one of the things, we did the FCA prior to a lot of the regulatory regulations that have been coming out lately. But doing a regulatory and incentive review to identify what federal, state, local regulations and billing performance standards are out there, but also to identify which incentives, rebates, and grants are available. One of the federal ones that we recommend a lot is 179D, which is for energy efficient improvements. So it could be anything from HVAC to lighting to plumbing upgrades. And another really great recommendation that we've worked a lot with is building relationships with your local utility companies. So if you go to their website, you may see a list of a few programs that they have available, but really building a relationship with them, a lot of times you discover that they are willing to help you, because if it's more efficient, it helps the overall grid and the system. So that's just another really big recommendation that we have, is build relationships with those utility companies.
Another advantage of doing a complete FCA of your facility is that you're able to see all the components that may need to be replaced over time. And that might give you the opportunity to bundle some replacements or some improvements in your building. For instance, bundling the replacement of a cooling tower and the roofing allows you to use the same crane, allows you to use the same rigging contractor. And basically you're hiring one general contractor instead of a roofing contractor and a mechanical contractor. So Richard was able to repair his cooling towers and lengthen them out until the end of useful life of his roof.
Yeah, we've been refurbishing, a couple towers. We have eight cells, and we've done about I would say 1 cell a year, 1 to 2 cells a year for the last couple of years. We do it on an as-needed basis, but and we replaced the drift eliminators and have done some other work. But that's all, and again, just to try to get these towers to make it to the point where they can be replaced in a phase section in a planned migration from our 2004 technology to our 2024 technology.
So the extra envelope, I was part of the 2018 Facility Condition Assessment Building Envelope Review team. And as you can imagine, with Richard's slide of all the different buildings and facades and years that these buildings were built, it was a very complicated and long list of issues that we came up with. So prioritizing all those really took a lot of work with facilities, with the stakeholders here who were amazing to work with. But what came out of that on the exterior? Well, what was the most impactful things that needed to be repaired at the time? What came up as the highest priorities were the low slope skylights, and I don't know if you've been able to see those, but they're over the lobby areas. They were starting to leak. During our facade review, we noticed major sealant failures. So we knew it was imminent that the skylight was going to be a problem. It was going to be very impactful because it was over the visitor lobby. There are 34 roofs on MoMA, all different materials, different ages, different remaining useful life. So it was a process going through trying to phase all of those and which ones were the priorities, which were the ones over the galleries that were going to leak. So all of those things were identified and looked at. And the facade sealants, we had so many different facades on these buildings. Combination of urethane sealants that last 7 years, silicone sealants that last 20, but trying to address the remaining useful life of all those systems, all boiled up to the prioritization at MoMA.
Yeah, and then of course, as Kathy kind of alluded to, there was the public-facing skylights that were done first, and most of them were public-facing, but some of them are actually exterior skylights, if you can believe that, but we have skylights on the outside areas as well. So not every skylight was replaced, but again, that prioritization of concentrating on areas that could be replaced while we were close to the public was emphasized here. Roofing, I think at the time the assessment determined that the roofs didn't need to be replaced, but they did need some maintenance, and that was performed. But we had somebody go through and do all the punch list items, I'll call them, on remaining maintenance items on roofs at that time. But we've just started replacing the roofs in the last couple of years. So we've done 2 last year. Hopefully we're going to do 2 or 3 more in the spring, and a couple more next year, and hopefully that adds up to 35 or 36 in another 3 or 4 years. So we'll see where that goes. But again, the roofs aren't necessarily all leaking. Some of this is preventative, but the facilities condition assessment provided us with the tool and the awareness that these things needed to be replaced in the near future.
So what are some of the recommendations for extending useful life on roofs? Regular maintenance, you probably all know that. Whether you have it in-house or hire a roofing contractor to come out annually to review your roofs. Make sure penetrations are sealed, flashings are working. It really extends the useful life of your roofs dramatically. If you are putting in a new roof or a replacement roof, it's always helpful to have a third party to review your plans and specifications. Do you have the right roof over the right part of your building? Are you putting a cheap roof over your most expensive artwork? Compatible materials, flashing details. It's really worth your while to have someone, an expert, understand and help you specify and plan your new roof. If your roof is in good condition, let's say it's maybe 15 years old and it's starting to deteriorate, but it's not leaking, which is the critical part, you can put a new membrane on that roof and gain another 20 years of estimated useful life without any demolition costs. The key there is that you put the new membrane on before it starts to leak, because then you've kind of lost your roofing system and you don't want to enclose that. If you're installing a new roof or a replacement roof, there is a EFVM system, and I don't know if you're aware of those, but it's an electric field vector mapping. It's a copper wire that extends around your roof and creates a field where you can determine where your leak is happening exactly in your roof. It's kind of a tricky system because it's a copper wire and it gets displaced and it's kind of difficult to maintain and keep it in place. But if you can install that and keep that in good working condition, it will pinpoint your leak instead of having to trace it back throughout your roof.
And I would just say one other thing. So when it comes to replacing roofs, typically when you think of code requirements, you think of new buildings. We're starting to see code requirements for existing buildings. So in New York and California especially, part of the California Green Building Code, you now have to, if you replace your roof, you have to add insulation, which then has other impacts. So how does that impact your parapet heights? How does that impact drainage, fall protection, and then also, coordinating that with solar or other items that you may have on your roof with equipment as well. So that's just another thing to keep in mind that is starting to pop up. It's in New York and California right now, but usually it falls to other states as well.
So understanding the phasing of your projects, part of the facility condition assessment. If you're going to be putting solar panels on your roof, you probably know this, you don't want to replace your roof the next year. You want to phase those items so that you're not going back and redoing things, having to take solar panels off. And if you can combine your projects, if you can combine your roof with the solar package or other things that you're doing in your building, you can bid that out, get more competitive bids, get contractors who are a little bit larger scale, will provide a better product for you in the end.
Yeah, well, we are considering solar for a couple different roofs, and we would combine them with the roofing cost. But the roofing cost actually is significantly higher than the solar cost, I think. I mean, I don't know why that is, but it's just because that's the way it seems like it turned out. But we are trying to coordinate those. If we do solar, we will do the roof at the same time.
I'd also just add too, so some solar companies do actually pay a portion or even up to full roof replacements as well. So just another thing to keep in mind if you're looking at solar as well.
So on facades, with museums, they are almost art pieces themselves, and they're difficult to maintain. They're difficult to access sometimes. You've got these 40-degree angles. So doing regular maintenance on your facade as well, checking windows, doors, areas that are potentially leaks to look at annually is really important. And if you do have a leak, hire a building envelope consultant if you can't determine where that leak is coming from. They can determine the cause and a remediation for that leak, and it'll help extend the useful life of that facade. Similar to the roofs and MEP, consider a holistic approach. Combine projects together so that you can bid the entire project and have contractors who maybe are of a little bit higher quality perform your work. If your museum is in a historic building, a lot of the new products, like the sealants, the mortar, the coatings, are not compatible with historic materials. You'll do more damage than good if you put them on. There is a resource, the Secretary of Interior Standards for the Treatment of Historic Properties, that is a great resource for you. It tells you what is recommended and what is not recommended for maintenance, repair, and replacement of your historic materials. And it will extend the useful life of these materials throughout the process.
So one of the things that we haven't really talked about yet is life safety systems. So I'm Steve Schneider. I did the fire protection life safety portion of this facility condition assessment. And MoMA is pretty, as you saw in the previous presentation, and what we're talking about now with priority-wise, they're pretty good at making sure that their systems are maintained and well-oiled machines. They have a wet pipe sprinkler system. They have a fire alarm system with mass notification. They have a smoke control system for their atrium spaces, and then they have a very extensive egress system throughout the building. two of the things that I want to talk about today that were identified in the facility condition assessment. The first one was their fire pump. And the fire pump had been around for a couple decades, and for the most part was performing as needed. But there's certain ways to look at fire pump curves during the annual test, and just other aspects regarding this particular pump that were not in line with today's standards. So MoMA prioritized replacing the fire pump and installing something that can maintain the sprinkler system pressure and pressure for the fire department, if needed. And then the other thing I want to talk about is their smoke control system for the atrium. That was something that MoMA had deferred the maintenance and testing of because there were concerns from the conservation department that the air velocity coming out of the smoke control system would have been too high and would have damaged some of the art. So it just hadn't been done. But after they they figured out a way to move art, right, Richard, move art and
provide temporary protection for sensitive pieces.
Yeah, to just be able to maintain the system. When they tested the system, they found hundreds of issues with different dampers across the system and across the building. And with an atrium like what they have here and a building what they have here, it's thousands of dampers. So a good portion of the dampers. So they've just been working over the years after that was identified to get the system back in place. And I think, according to Richard, down to like a dozen that are still an issue, that are hard to reach areas.
Yes. Our atrium our main atrium exhaust system is about 250,000 CFM. So you can imagine how much air that is. And then we have two other smaller ones, one for this atrium outside and another one in the expansion area. But it's like 15 or 16 different fans. Some run in reverse. Some return fans provide supply air. It's a very involved system. And our BMS, our smoke control wiring was actually through our BMS system, which made it even more complicated. And that's really one of the monumental tasks the team has now in upgrading our BMS system is just getting all these troubles down. And they've done a great job getting them down to like a dozen from, let's say, a couple hundred. Yeah,
it's a huge undertaking getting the BMS system and the fire alarm panel to communicate with each other. So it's not something that for thousands of points that I would want to do myself. So the other thing I want to talk about, and I think somebody asked during the last session about ways in which you can show the people who control the purse strings just the importance of emergency management preparation, and this is one of them. NFPA 909. Is a document, is a system that can help show your buildings, your organization's vulnerabilities, and determine and prioritize what the specific concerns are, and a way to move forward and address those. And those can tie directly into your capital improvement plan, and just a way to show get the people that are in charge of the money that we actually do need these systems, and get all the stakeholders on the same page. So what's shown up here is one of the checklists that NFPA 909 provides, and it helps to walk through potential threats as one of them. So everything from vandalism to fire to civil unrest, and it just really is a great document that if you can pick up a copy of it yourself, or there's consultants like us that can help you walk through the whole system. If you have more complicated buildings, more complicated systems, to really come up with certain numbers to help you get to where you and the rest of the stakeholders want to be. Because a lot of this goes above and beyond what the code requirements are. The codes weren't designed to really protect all the artifacts within museums. So really, you guys need to work with all the stakeholders to really determine what a path forward is to make sure that everything is protected the way that everybody can agree upon. And then the second slide here starts to get into more the operations aspect of it, and this was discussed in the earlier presentation. But NFPA 909 can also help to prepare organizations for potential emergencies, and what happens during a fire or an event. These are things operationally to work out after a fire, and going into the future.
Okay, so along the lines of resilience, as Steve mentioned, building codes are they're designed around life safety. It's not about really keeping the building operational, not to protect the contents. And so one of the guides being developed by ASTM, so I've been part of this working group for the past 3 years, it's called Property Resilience Assessment. And so you guys have all seen, especially recently with Hurricane Helene and Milton, the frequency and the severity of these natural hazards are increasing. And so the intent of this guide is to provide a minimum threshold for the industry of how to review buildings related to natural hazards. And so there's 3 main steps of this guide. And so the first one is to identify which hazards will impact your property or museum. And so there's a lot of different tools out there. We use a particular hazard screening tool, and so that looks at existing historical data, current information, as well as projection models. And so with that information, then we'll either go out to the site and, as part of the condition assessment or separately, basically look at all the systems envelope the site to identify vulnerabilities, and then the next step is to really identify resilience measures to harden or adapt the property, especially for museums, the building itself, but also all the contents, and often there's storage facilities for all the different exhibits and art pieces. So having those be reviewed as part of it as well is really critical. And then just another thing that kind of ties in, so this could either be for existing buildings or if you're looking to add a new building, really looking at the construction documents, thinking about resilience, how they respond to hazards, where it's located. We've been seeing increases in insurance premiums or just areas not being insured. And so building relationships with your insurance companies. We've done some assessments in Florida to basically look at the flooding. So we'll go out to the property, identify what's in place, and they can then take that back to their insurance companies to sometimes negotiate rates. So, in terms of overall resilience, no matter where you are, whether it's coastal, even, Hurricane Helene, that was 350 miles inland, and there was still a ton of storm surge and flooding that you wouldn't typically have thought would happen there, but we're seeing them happen. And so this is going to be published in the next couple months, and then starting next year, myself and then another lady from another consulting company will be providing courses and training on the guide since it's new to the industry. So just be on the lookout for this one.
And then vertical transportation, we mentioned its importance. Elevators have about a 20-year life, and MoMA's elevators were at that 20-year point. We prioritize these elevators to modernize all of the front-facing elevators, public-facing elevators, which is about 7 of them. Those are all done in about an 8-month or 9-month period, or maybe 1-year period in 2019, circa 2019. All the elevators had which was noted in the FCA, utilized an O. Thompson controller, which has, O. Thompson went out of business in probably around 2015. And if you were stuck with one of those controllers, you couldn't get parts easily, if at all. So we were able to, in modernizing these elevators, these public-facing elevators first, we were able to take the parts from the controller and use them as spares for our other elevators, which we've been doing kind of piecemeal over the last couple of years, and probably for the next 2 or 3 years we'll be doing an elevator a year. So again, the facility conditions assessment gave us the space to wait to do the other elevators that we could defer, and to prioritize the ones that we had picked up to do immediately.
So back to regulations and building performance standards. So as you're considering, replacing systems and overall maintenance of the building and of the equipment, It's crucial to ensure that you check which federal, local, state regulations and building performance standards are applicable. We pretty much are seeing them pop up nonstop throughout different jurisdictions. And so these are really setting the benchmarks and related to energy efficiency, carbon emissions, water use, and operational standards. And so by reviewing this, whether it's through a regulatory and incentive review, it's really, the whole idea is to really integrate so you have the most cost-effective approach when you're replacing the systems and maintaining the property. So here locally, there's local law 97, and so this was developed to align with New York City's goal to reach net zero emissions by 2050. And it is considered to be one of the most ambitious climate laws for buildings in the United States currently. So buildings that exceed the emissions cap after the 2024 utility data can face financial penalties, and so that is $268 per metric ton of carbon dioxide, and so that can sometimes be millions of dollars annually in fines. And so some clients are thinking of, okay, if you're going to be paying $2 million worth of fines annually, you have $2 million that you need to invest to improve your building. So we're starting to see building performance standards and regulations pop up throughout the country. Right now it's New York, Boston, Denver, Seattle are some of the major ones. But on this next slide, Richard will talk a little bit about how MoMA navigated Local Law 97.
Thanks, Courtney. So Local Law 97 coming soon to a jurisdiction near you. So this was, energy efficiency was not one of the criteria that MoMA was evaluating its projects on in 2018 when the facilities conditions assessment was done. I think Local Law 97 was on the drawing board at that time, but the specific, maybe you want to call it incentives in terms of penalties, or what the target was for, what was it going to be for a museum was not articulated at that time. So this was really kind of not really considered in the 2018, but soon after that, probably in 2019, January 2019 or January 2020, more of this, we got more clarity beginning with Local Law 97, and MoMA assembled a sustainability team. I see a couple of my colleagues here today, but MoMA assembled a sustainability team whose goal was to make sure that we're going to meet these targets. And there's, as I mentioned, there's intermediate targets in 2025. This will be the first year, January 1st. I think 2025 will be the first time we report for Local Law 97 based on 2024 energy usage. So, a lot going on. And what happened was we had a retro committee. Joe mentioned that earlier that we only replaced 3 of our 80 or so air handling units, and they recommended refurbishment of the rest. And what our sustainability team, and we have a team of consulting engineer, Rowan Butkus, we have a mechanical contractor on site, electrical contractor. The filter that people put things through to make decisions were based largely on energy efficiency and extending the life of the equipment. Because we knew we weren't going to replace our air handling units for at least a couple more years. That's still probably in the 3 to 5 year range. So we were able to basically go through every unit, every air handling unit, every system, chilled water system, heat exchanger, and figure out where there might be efficiencies, and figure out there might be deficiencies that were affecting performance, leaking valves, those kind of things. So we had a retro commissioning process. We use a platform called CX Alloy, which keeps everybody kind of on the same page. There's over 1,000 items, I think, that have been entered into it since it was put into effect a couple of years ago. It's administrated by our sustainability team, but it's a shared platform. So there's the BMS vendor is assigned to some of the tasks, the consulting engineer, there's some design issues that are really day one issues that have to be worked out. But these were some of the specific items just listed here. So as part of the 2018 Facilities Conditions Assessment, MoMA replaced all of its gallery lighting with LEDs. So that was a major, 4,000 fixtures. The 2019 expansion had them in it, but we also went back to the 2004 galleries and replaced all the lighting in there. And now what's going on is that they're basically we're going through the process of upgrading the LED fixtures in all of the back of house spaces. So that's, I would say, I guess it's probably like 75% done. The building we're in now is probably one of the last buildings to do that with. But many of the other buildings, all the other buildings on the 11 West 53rd Street campus have been completed. You know, one of the other things was we just make sure you're scheduling your equipment, make sure your air handling units are off when people aren't there, or running at a reduced speed, or possibly having a nighttime setback temperature. You know, we're 7-day-a-week organizations, a lot of us, but you know, many areas are unoccupied for a good part of the day, and sometimes on the weekends. So you should make sure that your DMS system is capable of doing that. Again, these were all areas that were picked up during the retro-commissioning process. You know, one of the things was our hot water temperature was always at 190 degrees. You know, 190 degrees, that's what it was at. The engineer said that's where it was in the beginning. There was no reset schedule. It was 190 degrees all the time. We did need it in the summer sometimes, maybe, but we found out through trial and error, through the retro-commissioning process, that we were able to reduce that from 190 to 160. We've had our hot water set at 160 for probably close to 2 years now. And I think we said 10% savings on the pressure reducing valves. I think this savings has probably been at us 20% savings on our steam. Just because you're thinking of the volume of water that we use, and it's 30 degrees, and just how much energy that is, it's really was a tremendous savings. So you might find tremendous savings in a very small, seemingly insignificant adjustment. Joe mentioned the steam pressure reduction, and then recently we did our chiller sequencing. We have a smaller chiller that we added. We have like an 800-ton chiller, and we have 3 800-ton chillers and one 550-ton chiller. And we found out that we were underutilizing. First of all, some of the 800-ton chillers are not very efficient. One in particular, we don't know why. They're 20 years old, so I'm not quite sure. But we were underutilizing the 550-ton chiller. We found that, you know, in most situations, outside the months of June, July, August, and maybe the early part of September, you do not have to run 2 large chillers. You can run 1 large chiller and a small chiller. And you know, that's got tremendous energy savings too, because the small chiller is the newest and the most efficient. That was installed as part of the expansion. And just one final slide. This is just a slide to kind of tag on to that. This is a slide from our consulting engineer, just evaluating the replacement of our chiller plant. This is just about replacing our chillers. And what you're looking at is, you know, a bar graph on the top of this is the existing plant. This is a scenario where we were going to replace the existing plant with like equipment, and these final 2 are just scenarios with different types of heat exchanger chillers. So you're looking at like basically our proposed, I'll find the button here, our proposed electric use, which is in purple, our steam use, which is in blue, and our CO2, which is in
metric tons.
In orange. This is the CO2 for the plant. This is the CO2 for the building and the impact. So just this is like the kind of exercise that having a facility condition assessment provided MoMA with the space and the time to really digest these issues fully. Not only just to figure out which is going to be the best system based on Local Law 97, but what is also going to be how to phase this. So we are, you know, basically what you're going to see is in our alternatives here is that MoMA is going to shed its steam usage, which is a higher energy impact than its electric usage. So you can see in the, you know, here we start off with using this much steam and this much steam, and by the time we're done, it's going to be this much steam. This does not include humidification. MoMA will still use steam for humidification, but you can just see that we're increasing our electricity under any of these scenarios and reducing our steam. And that's something that probably all of you are going to be looking at with just shedding your combustion sources towards electrification. I'm sure you've all heard about this, and it's a tremendous topic for discussion for our futures.
So lastly, Richard, at the beginning of the session, talked about the 5 buckets. The 5 buckets for the prioritization. Within those 5 buckets, there were hundreds of items that we found in our facility condition assessment. So how do you start prioritizing within these buckets all of these items? So we came up with a table that we took all of the potential failures, all of the events, and defined what was its likelihood of failure or having an event. And if it did fail or have an event, what was its impact? So with the stakeholders, with facilities, with everyone, and everyone was wonderful and very engaged to work with, we went through most of the items. Let's say the skylight we talked about earlier. It was starting to fail, it was starting to leak. So it was very likely that that skylight was going to fail within the first couple of years or so. What was its impact was severe because it was right underneath the visitor center and some galleries. So that's how it rose up to the very top of a prioritization for capital expenditures. And as Tunji mentioned before, you have to have proof. You have to have buy-in. This allows all the stakeholders to understand why you're spending money on your facade, why you have to spend money on your mechanical, electrical, plumbing systems, because there are impacts. There are issues with protecting the art. So that's how this prioritization chart came through, and it seemed to work really well. There was a lot of buy-in from all the stakeholders at the end. And with that, sorry, we're running a little over. We're going to open up for any questions. And
This gentleman has.
Jared or Johnny could run around with it.
I can just shout.
There we go.
Hi, Christian Davies, Smithsonian. I was wondering, how do you how do you get a multi-group FCA team to use a unified use the same kind of rubric so that each team's concerns are applied evenly, so that everybody, I'm thinking, my stuff is most important, the next person thinks their stuff is most important. But how do you kind of ensure that everybody's on the same rubric when you're doing FCA?
I think it is really up to the customer, and we can help navigate that, or whatever consultant can help navigate and help to direct the path forward to do that. But really, it's up to the stakeholders what is important to them.
Well, it's also presenting what are the severe consequences, or what is that end of useful life? How will that impact your museum? So it's really presenting all of the items, presenting the impact, presenting how much remaining useful life it has, and then letting the stakeholders make that priority. Plus, it's also the budget. How does this fit within your budget every year? That's a big part of the priority as well.
Go back to that grid a couple slides back. Let the stakeholders grade the various items. I think that's a great way to do this. I was going to say mechanical is most important. Steve's going to say fire protection, and probably life safety is most important.
Can I chime in? So I'm Jared Lee. I'm a vice president in Marx. I'm also the co-director with Kathy for museums. So one of the things I can say that, because we've done a lot of these FCAs, each museum is going to be different, right? So with MoMA, with SF MoMA and the Chicago Art Institute, we held workshops where all the key stakeholders were involved, and that's actually going to be really important. When you have different groups that aren't all talking together on a daily basis, when you actually pull them into this process and they listen to one another, and then all of a sudden they start to understand, oh, those guys have issues bigger than mine, then you start to get that group buy-in, and you get better overall understanding of all the issues that are going into the building. So that's something to think about when you're trying to do your own facilities condition assessment.
All right, just real quick, David's going to ask the last question here. If you do have more questions, please see the team afterwards. I'm sure there is more here. If you will, after this, please stay seated. Mark's got a quick announcement, and then we're going to get out of here.
Oh, can I ask something?
Yes.
Because we kind of lost like 10, 15 minutes at the beginning.
Four.
Or 4
Four,
minutes.
So, thank you very much for the great presentation, and no pressure that this is the last question, but it's actually a quick two-part question. The first, could you please define retro commissioning, because I'm an architect, so I'm not in that mechanical
Me too.
world necessarily,
No
but
way.
if I were to guess, to me that means you're going back to the design criteria and set points and everything that was maybe done for the 2004 renovation, and you can confirm that. And the second question is, was this prioritization done absent of cost information? Like, when did the cost information come through in order to make the decisions that the stakeholders were able to make?
Great question.
I can talk about commissioning. So commissioning, think of it as a functional performance test of something, a building, a car, whatever. You're going to test this thing under the known conditions as it will be operating. Retro commissioning is looking at a system and say, this thing's been there 20 years, it's bound to have changed. Let's go back to the original design criteria, which may or may not suit the owner's present requirements, right? So you got to confirm the owner's present operating requirements and then fine tune that system back to what it needs to be today. Okay, that's the commissioning. And the other thing was the cost. Our costs are immediately, we give them costs.
Yeah, and I would say that's, remember when you're defining projects from an FCA, the scope that, and the time and effort that, while it was enormous, that Marx Okubo put in to the process, it doesn't define all the scope. When you replace this unit, by the way, you also have to replace all the piping to it, or there's asbestos to it. So a lot of that stuff got, I want to say got lost, but it was inherent. The cost estimates that you're getting with an FCA are not what you would consider to be construction cost estimates in any way. They're really placeholders in a way, and you might have a square foot allowance, or they're using their best cost allowance numbers that they have. And sometimes you think there's even a big problem with something that there isn't a problem with. So we had like projects that we had $300,000 or $400,000 on that we didn't have to do because there was a much quicker, less expensive solution. But yeah, I would say, and that was always in I want to say an exclusion, but a limitation of the FCA. And I think we were given the opportunity to get better pricing information at some point in time, but we just didn't have the time. We didn't have the time at that point in time. We knew we were on the hook for a bunch of money, particularly before we reopened, and I think that's kind of the approach that we took.
Thank you.
All right, so thank you guys very much for
Thank you.
presenting. Sorry.
Thank you very much.